Hello, grade 5 sixes. Welcome back to our science lesson. Today we're going to be learning more about mold. Now, I know you guys did a bit last week, so let's have a little review of what we did and then move on to the new stuff. Okay, so last week when we did this, we learned what mold was. We learned that it is a microorganism. Okay, we learned how mold reproduces and spreads. It uses spores. Okay, and those spores get into the air, released into the air. They float around the air and land on something. They need to land on something that they can. They need somewhere where there is moisture, water, food, maybe like fruit or bread or something else, even wood in some cases, and it needs warmth as well. Okay. Now we learned that all of those things were required for mold to grow, and we also learned that mold was not always bad. Mold was sometimes very bad, like if you moved into a house and there was mold under the carpet or mold on the walls, that would be actually really quite dangerous to be living around that mold all the time. Those spores, you're breathing them in all the time, it could actually get really bad and you could actually get an infection from being in there. Yeah, mold is sometimes very bad, but sometimes it is good. Okay. For example, when mold is on, well, we use certain molds for cheese. There's blue-green sort of cheese, like blue mold cheeses. They can be very tasty. Even Camembert and things like that can have a type of mold on them. Okay, which is very yummy. Then we also learned that mold could be used to decompose rotten fruits or vegetables or foods and turn it back into dirt. We watched a video about that last week. So rather than having lots of dead and rotten things lying around everywhere, mold and other things turn them into dirt. Those microorganisms turn it into dirt and clean it up for us, which is great. So then fresh things can grow there. Okay, and today we're going to be learning of another very important, useful thing for mold. But before we do, I want to show you guys the bread. Last week I attempted to get some bread and make it moldy. And weirdly enough, it's not very moldy. It's only a tiny bit moldy. In fact, I'm going to show you guys a picture I put up of it. I zoomed in to try and show you. This is actually one side of the bread. And mold has started to grow, but not very quickly. Okay, you can see I've got little white clumps of mold. Here's one, there's another, more up here, more up there. They're growing around the place, okay? And the mold has started to grow, but it's not growing very quickly. In fact, it's growing a bit slower than I anticipated. This side actually grew underneath the bread on the counter. The side that was facing up was getting, I think, too much light, and that was slowing the mold down from growing. But the bit underneath started to get moldy, where the light couldn't get to, the sun couldn't get to, because mold likes it dark. Okay, so I've put the bread back in the cupboard where it's a bit darker, and I'm going to let it keep growing, and we'll check in on again next week. Now, the main reason this bread wasn't getting very moldy, however, was actually because I have used bread from the supermarket, which has preservatives in it. Boys and girls, we deliberately put preservatives in food because preservatives keep the food good for longer. That slows down things like mold growing, so it's harder for mold to grow. Okay? So if I had used fresh bread from a bakery or bread that I'd baked at home, it would be much more moldier because it doesn't have any preservatives. But because I used bread from the supermarket, that bread was from Aldi, it actually lasts longer because the ingredients we add to it, preservatives, keep it fresher for longer. Preservatives aren't really good for us. Okay, they're actually better to get fresh bread and home cooked bread. I mean, it is better for us, but sometimes it's helpful, obviously, because then it keeps our bread lasting longer. Okay, so I've got that bread in the cupboard. We'll check on again next week, and hopefully the mold has continued to spread. Okay. Now, this week, we are learning one extremely useful thing that mold is used for, okay? Now, I've got a little picture of it here. Okay, the mold we're going to be learning about today is called Penicillium. Okay, now Penicillium is this bluey green sort of color here, okay? And this was a type of mold that has been used for one of the most important discoveries ever. Okay? We're actually going to have a look at that now and learn all about it. Now, in the Google Drive, I've got a Google Doc that you should be able to click on and called penicillin. And I want you to read through this with me. Or you can watch it now, but it's there too, so you can review it and look at it. I've got this whole thing there, and I'm going to read through it with you. Okay? Now, as we go, I'm going to talk a little bit about it because there's quite a bit here. Okay, penicillin, the miracle mold. So penicillium is that blue-green mold I just showed you. Okay, substances that prevent the growth of germs, bacteria, are called antibiotics. Okay, now there's a few things there. Remember, boys and girls, bacteria are germs. Okay, germs is what we call a word we use for bad bacteria. Not all bacteria is bad. Okay, but germs are bad bacteria. Bacteria are microorganisms. So germs are bad microorganisms. When we get someone's germs and they're sick, they've got a cold and they give me the cold or something like that, then I'm getting the bad germs and doing it. But there's lots of different types of bad bacteria that we can get, and things called antibiotics stop those germs from spreading. Okay? So they're very important. All right? So substances that prevent the growth, that stop the growth of germs, are called antibiotics. Today, many antibiotics from different microorganisms are used to treat various infections. Okay? The first antibiotic used for medical purposes was penicillin, which is made from a fluffy blue-green colored mold called penicillium. Here it is again. So this mold is a very important mold that's used to make penicillin, okay? And that's basically used for medicine. All right, let's keep reading. In 1928, British scientist Dr. Alexander Fleming was working at St. Mary's Hospital School in London, England. He noticed that a mold had contaminated a dish containing a sample of bacteria he was studying. So this scientist was purposely growing some germs, some bacteria, just to study them. And he noticed that for some reason, one of them had accidentally got some mold growing in with his bacteria. Okay? Dr. Fleming observed that the bacteria could not grow in the area around the mold. Okay, and he published a journal article on his observations in 1929. However, he was unable to isolate the substance that prevented bacteria from growing, and he moved on to other research. So basically, he was growing germs, one of them accidentally got moldy, and the germs wouldn't grow around the mold. And he thought that was really interesting, but he couldn't really figure out why the germs weren't growing. So he told people about it, but then he moved on to other things. 10 years later, Australian researcher Dr. Howard Florey, biochemist Dr. Ernest Chain, and their team began to look for the substance that Dr. Fleming had observed. So this is 10 years later, and they read his stuff that he'd written and thought, let's see if we can figure this out. In 1940, Dr. Florey and his team at Oxford University in England infected 8 mice with streptococcus bacteria. Okay, so what they've actually done here is they've actually got 8 mice and with a needle given them these bad bacteria. Streptococcus bacteria is a streptococcus microorganism, is bad and it would kill the mice. Okay, and so they purposely gave 8 mice this bad germ. 4 of the mice were treated with injections of penicillin from the mold, while the other 4 were untreated. They didn't get any penicillin. The next day, the treated mice who got the penicillin had recovered, while the untreated mice were dead. This experiment demonstrated the potential of penicillin as a treatment for bacterial illnesses. Let's have a look at this, okay, guys? Here's a little chart about what we just read. There were 8 mice to begin with. So here's the on the side: 1, 2, 3, 4, 5, 6, 7, 8. Okay, these 4 were given that's infected with that streptococcus virus, but they didn't get any of the penicillin medicine. These 4 were also given the bacteria, the streptococcus bacteria, but they were also given some of the penicillin from the mold. So this is a way to see if the penicillin from the mold actually saved them or not. Okay, so 2 hours later, you can see they're all still happy here. 6 hours later, they're still alive. Okay, but 12 hours later, one of the mice that didn't get the penicillin had died. And by 16 hours later, all of those mice had died, but all the ones that were given the penicillin were still fine and were fully recovered. They were all better. So this showed just how effective penicillin was at curing things infected with bacteria. Okay, let's keep reading. The results were so exciting that Dr. Florey knew it was time to test penicillin on humans. In 1941, Florey's team gave penicillin to a policeman, Reserve Constable Albert Alexander, who was dying from an infection caused by a scratch. All right, now, boys and girls, this is actually important. This is something that used to happen all the time in the olden days. Okay? What would happen is people would get cut or step on something sharp, or even in the war, they would get shot. Let's say they got shot in the arm. And the bullet or the cut or the thing they stepped on wouldn't kill them. But bacteria and little microorganisms, bacteria would get into their cut and infect it. And the bacteria would start to grow and eat and spread, go through their bodies and kill them. In fact, most of the people that died from those wounds died from the bacteria, not the actual injury. Okay? And so here was a policeman who was dying because he got a scratch. That's actually why your mum or your dad or even your teacher will say when you get a cut, make sure it doesn't get infected. Okay, they'll make sure you wash, that your cut is clean, and that you put a Band-Aid on it, and that you check to make sure it doesn't get an infection. Because if it does get an infection, you may need to go to the doctor or the hospital to get antibiotics to stop the infection. Okay, so they were going to test this on a human. This policeman who got a scratch. He was dying. Okay, he began to recover after being given penicillin. So the policeman started to get better. But then they ran out. There was not enough penicillin to see him through to recovery. Unfortunately, the policeman died. Because of this experience, Dr. Florey's team worked with sick children who did not need such large amounts of penicillin. Because kids are smaller, they didn't need as much of the medicine. Okay. Florey's team became determined to find a way to mass produce the penicillin, to make as much of it as they could. Due to World War II, companies in Britain were unable to help with the project. So World War II was happening then. So Florey took his discovery to the United States to develop it. By late 1943, Florey and his team had discovered better methods of producing penicillin, and mass production of the drug had begun. So they started making heaps and heaps of it. Okay? The availability of penicillin saved the lives of many Allied servicemen who might have otherwise died of infections from wounds or surgery. So it saved the lives of lots of soldiers, because this was World War II. This was massive. Lots of fighting, lots of killing, and lots of people getting cuts and scratches or wounds or surgery. And penicillin saved lots of their lives. Okay? However, penicillin does not work against all types of bacteria. All right, so it actually saved lots of people, but sometimes, depending what microorganism would get in there, penicillin would stop some of those microorganisms, many of them, but not all of them. Okay, so some of them it didn't work on. After World War II, penicillin became available for civilians. Okay, that means regular people. In the war, they only gave penicillin to the soldiers and stuff because it was really hard times and the soldiers were really at risk. But once the war ended, they had enough that they could give it to everybody who needed it. Okay. In 1945, Howard Florey, Alexander Fleming, and Ernest Chain were awarded the Nobel Prize in Medicine in recognition of their discovery. Now, this was a huge, huge discovery, boys and girls, and they were given the Nobel Prize because of how big it was. Now, the Nobel Prize was a special prize awarded to people who did something great for humanity, really served to help people. Okay. Now, it's estimated that penicillin that these guys developed has saved over 200 million lives. I mean, that's more people than are in Australia, far more people than are in Australia. Okay. So they saved so many people's lives with this scientific discovery. Interestingly enough, the Nobel Prize, that actually started by the person who invented dynamite. The person who invented dynamite came up with, he was a scientist, he came up with this great discovery he could use to, dig big holes, blow up, help with mining and getting resources and all these useful things. But then, of course, people started using it in weapons and started to make bombs and explosives. And he was so upset that his discovery was being used to hurt people that he actually invented the Nobel Prize. And he said, no, I'm going to give prizes to people who, for scientists and other people who do things that help people. And so Dr. Howard Florey and his team definitely fell into that category, and they were given the Nobel Prize because it's one of the greatest discoveries, one of the greatest medical discoveries ever. Okay, I've actually got a picture here. That's Howard Florey. I've got a picture here of Alexander Fleming. You can see the penicillium mold that they used. And I actually reckon that some of you here would probably have received antibiotics like penicillin. In fact, I know people who would have died if they hadn't had those drugs. It really is so important. The penicillin, we just call it a drug. It's a drug that we give, and it saves people's lives. In fact, it might have even saved some people's lives in our school. Lots of people's, I'd say. So, boys and girls, this is a very interesting piece of science and also a very interesting piece of history. What I want you guys to do is I want you to write a summary of what you've learned. Okay? Write a little bit about penicillin, why it's useful, that it's a microorganism. Tell me what you've learned about it. You might even want to research a few things of your own about it. Okay? And then after that, I want you to tell someone at home. Okay? Explain it to them. Tell them about it. It's a really interesting thing. Share it with someone at home. This is a fairly big video, boys and girls. So the task isn't too long, but I still don't want just 1 or 2 sentences. Give me a good chunk of writing, okay? And then next week, I will have another topic for you, another lesson. All right. Boys and girls, I hope you found this lesson interesting, and I will see you again next week. Catch you later, guys.